Hello everyone, my name is Sanjeev Kaur and I'm the co-founder of RSC Asia. So this is a 6 episode series that we have been working on, and in this specific series, we wanted to discuss on the importance of how you would share your code or software and any data that comes along with that software. Specifically things like what is the process of citing a software and what are some practical advices if someone is starting to contribute to a software or wants to reuse available code. So we'll be talking with our invited speakers and try to understand how they would navigate such situations. Uh, this could be helpful for anyone who wants to create their own small project, or if you aim to use an external library or code in your work, or if a group leader who is looking to balance open science principles in their group with a long-term strategy, so how they could do that. Um, why this is important is because for example, you come across a code or a piece of software or data that you want to reuse, and you so when you come across this code, you perhaps tweak this code a bit or remix the code with some other data. But like when you are about to publish it, some critical issues arise, like you see there is a lack of proper license on that software or code that you modified. And then while you are very eager to publish your work, you don't know how to do this properly. So you might end up publishing your paper without the software or the data. And then this essentially also reduces the chances or the opportunity for others to build on the work that you were building. And it might also reduce how many citations you get. So that could be one situation. Or you might come across a journal which says that they won't publish unless you share the software and the data for better reproducibility, and in which case you end up not being able to publish your work at all. So in today's episode, we'll essentially talk about such situations, or such critical situations which we come across, and as software developers, and how you could use or reuse someone else's code, and how you could make your code also open to others for use. So how you could appropriately use license, or where could you really publish your code, and what is like the more ethical way of doing all these tasks. So with that, I'll hand it over back to Anelda for the introduction of speakers.
Hello, all, and welcome to the episode 3 of this series. I'm Jyoti, I'm based in India, and along with Sanjeet, I co lead RSC Asia Association, where we focus on promoting research software engineering roles in the Asian region. And I'm really looking forward to all the conversations that we will be having today. Yeah.
So, without further ado, I would like to introduce our speakers. We're very fortunate today to have five speakers from very diverse backgrounds, very different experiences, and really looking forward to hearing what you have to share with our audience in terms of how they can improve their opening up of their code, why they would like to open up their code, and just talking generally in how we can make this whole ecosystem more efficient. So we're going to go alphabetical, then everyone know who's up next. And we're going to start with Adinka. If you would like to introduce yourself, thank you very much.
Thank you, Hanelda. Hello, everyone. I am Adeyinka Oresoya, and I work as a software engineer, specifically as a backend engineer. And what I do is that I am behind the logic that has to do with the application that you see. So what I do currently, or let me just start with the interesting background that I have. So I have my three degrees, BSc, MSc, and PhD in agricultural extension and rural development. So for the better part of my education, I've been doing research before I discovered programming and software engineering, and I decided to go full time into that. So currently I work as a backend engineer, but I also contribute actively to open source, and I am a maintainer of some of the projects that we have in a community called Chaos, which is community health analytics open source software. So that's me.
Thank you so much. Exciting to hear about your shift from research to coding and also how you're working across those two domains now. Chioma, tell us a little bit about yourself.
Hello, everyone. So my name is Choma Onyido. I am a bioinformatician and a microbiome data curator with a background in biochemistry. I entered into coding few months after my master's program. So I have a BSc and master's degree in biochemistry. So I decided to explore, coding and bioinformatics because, I've always been fascinated and amazed by how computational tools can, tap into all those levels that laboratory methods cannot always reach. So that's why I decided to go into coding. And so far, so good. It's been an exciting journey, combined, especially that I'm in the research field. Um, yeah, so that's basically what I do. Thank you.
Thank you, and thank you very much for joining us. We're looking forward to hearing about your experience as well, and specifically your engagement with communities of practice where you get more mentorship and training and also give mentorship and training. Juan Pablo.
Hi everyone, my name is Juan Pablo. People call me Juanpa on the internet. Currently in Delhi, in India, visiting for a friend's wedding. So for everyone in India, this is the time for weddings. But I'm a senior program manager at the GitHub education team, where our job is just supporting people to get started with coding and get to know more about how they can use GitHub on their work. Um, I'm originally from Mexico City. I studied computer engineering, and through my time, I did like a couple of things. One of them was supporting students to create code through hackathons and just general events. So a lot of the hackathon culture in country and Latam was something that we brought from the US to Latin America, and it was extremely successful. And it was great to see people from all backgrounds building the craziest projects. And through that, I ended up also working in research, which at the time it was not called research software engineering. It was just like someone that researchers needed to build code for them, and I was just having a couple of like free hours every day to help them out, and that ended up with me working for um, Stanford University on crowdsourcing studies, and for CMU on how on human computer interaction, specifically after kind of like before the pandemic, like how live streams and how like we could use like live streaming as education tools, which ended up building a couple of tools there for people to analyze Twitch audiences online, and this kind of like open source, so everyone can take a look at that. And yeah, super excited to join you for this talk about like if there's any questions about like how to use GitHub as infrastructure for research software. I'm super interested in helping out, and my job here is to help you be successful with that.
Thank you very much. And it's interesting that you refer to the title research software engineering, because I think on the African continent, research software engineering isn't a known job, really, although so many researchers do software development and write code. But I don't think many people relate to the term research software engineer yet. And it's a question of, is that the real term that we should be referring to going forward? But also excited to have you here because I think GitHub plays such a massive role in the research software ecosystem at the moment in terms of making code available, whether it is scripts that support publications or whether it's tools that support large-scale scientific discovery, GitHub is pretty much there, along with some of the other repository and version control tools and collaboration tools. But thank you very much for joining us. Mars, we're so excited to learn about your work. Tell us a little bit about it.
Hi everyone, I'm Mars. I am a technical illustrator focused on creating visual documentation for NumPy. The easiest way to explain that is a little bit over here. These are indeed comics. It has characters, it has storylines, it has dialogue, but ultimately this is telling the story of open science, open source, and research software engineering. I have a physical copy over here. I've given out copies at conferences such as PyData in New York City, PyCon India, and more. I will actually drop a link in the chat because that is the easiest. Oh, I can see Jyoti have a copy right over there. Yes, yes. So I gave a copy at Jyoti when I gave a keynote on this at PyCon India, but that is what I do. I am an illustrator. I'm kind of the wild card of open source. I'm going to go through some of the other questions real quick. Where did I study and where? I was born in South Korea. I grew up in Singapore and I'm currently in New York City. It's 3:30 a.m., but I'm still here because being international and sharing my work and my research internationally is really key to who I am. So this is what I want to share right now. I'm going to be honest, I don't have a lot of postgrad qualifications that other people have. I don't have a doctorate. I don't have a master's. In fact, I do not have a bachelor's. In fact, I dropped out of college, but that is because life has led me to a different path, and this path that I'm on right now. And so while I may not have the technical, like typical experience of people who are in research software engineering, I've met a lot of my colleagues and my coworkers in my time working in open source who have done research, who have done PhDs, and through doing interviews and understanding their perspective, I have created a story about, creating research software engineering. And so what I do essentially make open source more accessible to underrepresented populations, such as designers, students who only hear about open source maybe through their classes, and I teach workshops on making open source more accessible, such as Git for designers. I know Juan has talked about Git right over here. So for me, it is how do I take what I care about, such as design and underrepresentation, and how do I combine it with other fields such as research, engineering, and all that over here. That's
Thank you
my
very
introduction.
much. And thank you for highlighting your educational trajectory, and I think one of the things that people in the audience should know is we try and be purposeful about inviting people with diverse backgrounds and diverse career trajectories, because and I'm sure Ajenka, you can talk about what you see in the chaos community in Africa as well. People come from all places and make a difference. And I think, especially in Africa, you don't need a PhD to do impactful work. So everyone is welcome here. In fact, one of our so RSSE Africa runs a bi-monthly spotlight of a community member, and we're just about to publish our December spotlight. And that will be for a colleague that I met through a different program. And he is an undergraduate and doing such fantastic work, developing software that makes indigenous languages more accessible. So yes, wherever you are, with your PhD, with your postdoc, as an undergraduate or a scholar, like you're welcome. You can make a difference here. I also saw Adyenka was sending lots of hearts. I have a feeling there's already a collaboration opportunity developing there. And that's also why we have a number of speakers, to ensure that this is a platform where people can connect and continue to collaborate beyond these conversations. Finally, Kate, thank you so much for joining us for the December session.
Thank you very much, Anelda, and hi everyone. So I am a senior lecturer at Stellenbosch University in the Department of General Linguistics. I'm a linguist. I teach linguistics, and I do research on South African Sign Language. So that's who I am. I did my undergrad and my MA at Stellenbosch, which is in the south of South Africa, just outside, about an hour from Cape Town. And I did my PhD in Utrecht in the Netherlands. Yeah, last year I did. So I've always been interested in data, and especially at the moment building a corpus of South African Sign Language. That's one of the projects I'm involved in. And last year I did an introductory course with on R, and it kind of opened up a whole world for me and my research. And so now I'm using this open source software to do my data analysis by myself, learning as I go, and finding resources online, other people's code, which I'm then able to use in my own research. Haven't quite contributed yet, but and yeah, so that's where I am, and that's how I'm hoping to contribute to the conversation.
Thanks, Kate. I met Kate in a meeting also on another project. And when I heard how she was using code that she finds online to kind of build from, to not have to start from scratch, I immediately thought this was a really, really good person to have in the room, because often we have all the developers in the room and we talk about how we make our code open, but we don't ask our users, is it useful in the way that we're making it open? So thank you very, very much, Kate. Your perspectives are also very valuable. Yes, an R user and a fresh new R user. So I'm very, very happy to have you here as well. So we're going to get into the meat of today's event and start with our panel discussion. And we would like to ask our speakers and open the floor by asking, what does it mean to make research code open? And what do you think are the benefits of making research code open? And we're going to alternate a little bit between the speakers. For this one, we're addressing this to Adinka, Juan Pablo, and Mars Lee. And then you're welcome to speak in that order and talk to each other any way you want. And then we can also see what other people are saying. Thank you.
Okay, so I think I will start. So what does it mean to make your research code open? It's essentially you publicly sharing the code that supports your research in such a way that others can use it, they can modify it, they can redistribute, and then you have to put like a license that defines how the users are going to use it. So sharing it publicly also means that probably you then get to host that code in a public platform like GitHub, GitLab, Bitbucket, all those ones are public version control systems. Hyuan is here. I'm sure we're going to be speaking more to GitHub, right? So that's it. Juan, would you want to add to this?
Totally. I completely agree with that. I think one of the best ways that we can support people to continue to trust science and the work that we're doing is by making it more transparent and accessible to everyone. And not only showcasing the results of our research, which a lot of the times are seen as publications, but also the mechanisms and the other products that our research has been going through. And that goes not only with code, but also with data. So being able to share code openly, and as you mentioned before, right, like making sure that it has not only the access to the code, but also giving some documentation, providing a readable piece of code, providing readmes, and providing licenses that everyone can understand how to use your code and cite it afterwards, plays a fundamental role in continue to make sure that science is not only something that people trust, but also that people can reproduce that research that we have done, and also continue kind of like to develop and build on top of each other's work without the need of reinventing the wheel 1,000 times for everyone that is trying to do a similar research or something close to the work that we're publishing. So we've seen benefits that go from reducing the cost of doing research, like using other tools, make sure that we are kind of like building together these resources. And on the other hand, like for research institutions that perform really well with research, it becomes one of the main mechanisms to continue funding the work that they're doing. So there's so many different benefits that we've seen about opening the research code that you have, and I don't know here. I forgot who was next on the talk, but like I would love to hear from like everyone on this side.
Max, would you like to add
Ma-
something?
Yes, I am next, so I would like to go forward with that. So, I am exactly kind of like the weird outlier. Like, I may not have code per se, but I have something else that I think is essential to making open research more accessible, and that is opening up and demystifying the process of illustration and storytelling in the context of open source. So, again, I am a firm believer of show, not tell. So, I will actually drop a bunch of links in the chat that will show exactly that. So in the chat, I've dropped some of my repository. So I am a designer, but I do use Git and I use GitHub because I do believe it is a very powerful platform. And that is where I can intersect and meet with the programmers that I work with on the day-to-day. I also have a talk that I gave at PyDate in New York City last year that talks about what is this process of bringing art in an underrepresented skill set. What does it feel like to be the only person of a group or a skill? And how do you bring like the strength of that forward? Along with my blog posts on logistics, like how did I get a grant to make a comic? How do you work with, how do you explain this as documentation? And how do you work with the community from maintainers to newcomers to regulars and convince and onboard people on this kind of interesting big project. So that is the big part that the links will explain a lot over there. But I'm kind of thinking of what Anelda mentioned about feeling powerless in a language exchange where you have a translator and you only know one part, but you don't know the other. And there's something bigger happening and you're really curious what is going on. That isn't a power exchange. And I am someone who delights in, like giving people, making people feel empowered in this process. And so one version of that is people tell me, oh, I can't draw, or oh, I want to tell my own story in open source, but I don't think I'm capable. And one of my missions in my life, in my workshops, is to enable people to tell their open source story. So when I was in PyCon India, and that's when I met Jyoti, I held like a mini sprint. It was about 1 hour called "Tell Your Own Open Source Story." And so I told people like, "Hey, you just saw a 16-page comic, but I want you to tell your own story in 8 pages in a smaller format." And so I have some examples over here that people wrote. One of them is about Czar and sharding. That one was really powerful because it went to some of the technical information about sharding and explaining it in a really like easy to understand, ground down to earth way. There was also someone who spoke about their experience in PyCon and like learning from the talks and meeting like different people and how that was like so educational. And so for me, like part of sharing open research code is sharing my process, sharing what it means to be an artist, and enable other people to create their own stories and art about open source, because the code is like one outcome, but the process and the feelings and the community and the connection are something that I really want to enable people to do.
Thank you, Mas. Yes, it's a big deal, you being able to share the process of your work. So I would like to add to that and kind of tailor it to research, right? Some of the benefits of actually making your research code open is number one, validation. You want people to be able to see your research as something that they can be trusted. Because when they see your code and your data and they are able to reproduce it and it gives them the same result, the same findings that you already specified in your publication, then they are able to you kind of have credibility. They are able to trust your work, and then you have more citations, and then as a scholar, more citations mean more credibility for you. And another thing is that it's becoming increasingly popular for funding organizations to make it a requirement for you to make your data open and your code open, if they are going to be funding you. So that's another reason that you have to consider making your research code open. And another beautiful one, which I would support, is collaboration. Collaboration is at the heart of open source, open science, so that you make your code public in such a way that people are able to even build on what you have done. They are able to even look at your code, look at your process, and say, "Hey, there's a bug here, or there's something we can improve here." I know that nobody really likes to be criticized, honestly, and so that can even be a fear for us researchers to say, "Oh, I don't want to share my code. I don't want to share my process. What if somebody comes on GitHub comment section and then begin to say, oh, this is not good, and you call yourself a scientist or something?" Science is meant to be rigorous and all that. But then open science, open research code invites people to come to your repository to say, hey, it's not perfect, but I am willing to accommodate improvement from other scientists like me. Thank you.
Thank you. Yes, I really, really like everything that you shared about making code open. I think there's also perhaps an opportunity to talk about like the first steps to opening code. We're talking about licensing and readmes and maybe things that researchers who are just venturing into opening up their code might find a bit daunting. Are there things that you have seen that are like easy first steps to opening up your code, even if you don't know about licensing, or like should you be sharing your code if you don't have a license on? That's my one question. And the other thing is we're also talking about making code open for other people, but what about I think what I've been enjoying from the series is that all the episodes fit so nicely together. And what we discussed last month was that you should be your own best collaborator. And many of the practices we discuss here makes it easier for you to use your own code in future. So are there also aspects of opening up your code that makes your own life better even before you start making other people, having impact on other people's lives? I don't know if there's some comments maybe from our speakers.
I mean, I can talk for hours about this because there's in GitHub, some of the things that we're trying to do is how do we make the process of sharing code easier for everyone, right? The whole idea behind GitHub is that the most important piece that you get is kind of like building the code, building the project, building these ideas into reality. And then GitHub facilitates the process of sharing and the process of maintaining this code on the platform. And there's very few things and very small actions that researchers can do to open the source code of the research, but that we haven't seen. We've seen some specific adoption to it. For example, some things that are not very well known about GitHub is that we have enabled ORCID integrations with GitHub profiles a couple of months ago or a few months ago. Today, we have around 100,000 researchers or users that have connected their ORCID with their GitHub accounts. And that kind of like shows the size of the audience and the size of like research on GitHub as a platform. But on the other side, when we talk about like repositories that follow kind of like the best practices that have been shared in the past, things like FAIR principles or open source community standards, we've seen kind of like a strong variety of different approaches about or different usages. Another great tool that we have enabled recently was citation files. So people who use a citation file on the repository, we can render the citation information for their code on a GitHub repository, and that facilitates the process of just referencing the code or the repository itself. And I think it takes just like a few minutes to do that, and that helps a lot, kind of like not only us to like identify research projects on the platform, but also for people who are doing research on software engineering to identify the projects as well and facilitate this process of making your code findable for other researchers. Additionally, things like adding topics to your repository, which is kind of like a very underutilized feature that takes just like a few seconds to just add to your repository. Like this, a research repository can help us out to create like a catalog of research projects on GitHub. And then if you want to go even beyond that, adding things like, not only this is a research project, but this is like an astronomy project, a biology project, going more specific, helps out to people to filter out the projects that you have enabled. And then from there, things like licenses, we have built a tool. Whenever you're kind of like choosing a license beyond the creation of the repository, when you are creating your own license, you will find additional details that will help you summarize which license might be the most useful for the project that you're building. So these are just like a few examples of things that we have been working on to make the process a little bit easier. We understand like there's a very slight balance between being productive as a researcher, meaning like doing the code and doing the publication, and then like this additional work of how do I make my code useful for other people? How can I make it accessible? How can I make it so that other people can utilize it on their own projects? But what we found is that very, very small steps go a very long way to making sure that research software is not something that only runs on your computer, but can run in any other researcher computer as well. And we can talk more about it, but I can pass the microphone to someone else as well.
I would actually like to chime in of how the intersection of research code affects someone who is not formally in research or academia. So as I mentioned before, I have worked with researchers in open source for a number of years, while I might not have some of the formal background. And recently, within the past month, I've taken a training provided by NASA and a company called Don't Use This Code. If you heard of James Powell and his many Python talks, he was also a keynote speaker at PyCon India. But I went to their training for Transform to Open Science. And again, I could drop a link in the chat because that makes it a lot easier to understand what I'm talking about. But as Juan mentioned, was ORCID IDs. Like I learned about ORCID ID actually through that training, and I've not linked my ORCID ID to GitHub, but now I should, now that I know about that. But it kind of put it into perspective of what I was already doing in GitHub as a designer, as a programmer, and link it to research and research software. The things like citation files, adding topics to your repository are things that I'm definitely going to keep in mind. But some of the things that kind of tie to what I already do, such as making blog posts. As I mentioned, I made a blog post of what it's like to be a designer in open source. I realized, oh, that is actually a form of writing, a form of publication, and that can actually be a citation that I tie to my ORCID ID. And in some way, I hope that helps with the reproducibility crisis that people are facing in various different fields. But I think it's really exciting to see how what I'm already doing is like intersecting with open science and what are the gains that people have with open science more broadly.
I love this conversation. Thank you so much for sharing the very practical suggestions that is quite accessible to people who are even very, very early in their journey to making the code open. We're going to move on now to speak to Kate and Chioma about how they have been using open source tools and how that has helped them in their research. Oh, there we go. Excellent. So Chioma, would you like to tell us a little bit about how you've used open source tools in your research and how that has helped you?
Yes, thank you so much. So one thing I left out in my last talk where I introduce myself is that I didn't state my current role. So currently I work as a bioinformatics research assistant in Covenant University in Nigeria. So here I'm currently exploring how to improve risk prediction models for Africans, generally underrepresented populations. So if you're talking polygenic risk scores, GWAS, post-GWAS, and all of that. So here I'm developing algorithms and using existing computational tools. I also double up as a microbiome data curator and mentor at Bioconductor. So if you're in bioinformatics field, I'm very sure you're familiar with Bioconductor. So one tool that has really, improved one open source tool that has really helped me in my research is, Bioconductor. Bioconductor, if you're not familiar, it's a rich ecosystem that, provides a range of packages for biological data analysis. So for different tasks like, differential gene expression analysis, annotation of your genome, for any analysis you want to, for most analysis you want to perform in bioinformatics, we have packages for that in Bioconductor. So there's this function, if you're familiar with bioconductor, bioinformatics, and R, when you want to install packages from CRAN, we use the normal install the packages function to install. But sometimes, it will throw back an error, especially when you want to install specific bioconductor packages, like, let's say, for example, um, maybe Boxic DBR or Biobase for conducting your analysis. So when you use the normal install the packages function provided by RCRAN, it makes it a bit, it could throw back an error of packages not found. If you've experienced such error before, you to see packages not found error, or your package is not compatible with the current, because bioconductor packages, we release um updates twice a year. That's every 6 months. So it's not the same for RCRAN. So sometimes RCRAN, they don't have the most up-to-date package for that particular analysis. So it's very, advisable to use BioManager install function when you're installing packages in Bioconductor. So yeah, in a nutshell, yeah, Bioconductor has been very helpful in my open source journey and my research code. It is some specific um, features about that bioconductor brings. We have for each package, there's a landing page for each package, and then there are citable DOIs. So if you go to I think I'll share the link when I'm done talking. Like, if you go to a specific package you're interested in, you'd see the DOI in case you're interested in citing that package. You see the vignettes, you see user manual, you see different package build reports for that specific package. And if you're interested in workflows like, gene expression, immuno-oncology, proteomic workflows, spatial transcriptomics, all of that is available in Bioconductor. So yeah. Thank you.
Fantastic. Thanks, Chioma. It's really interesting that you're talking about the whole ecosystem of this open source environment, because what you get there is training, you get the open source software itself that you can use, and you also became someone who is contributing in this ecosystem. So that's, and I saw that Diego was asking a question which we'll get to later on, but some open source or some software that you can reuse have that expanded ecosystem around it, which is fantastic. And some of them obviously are very far on the other side. It's like single people trying to maintain something or supporting something or putting something out there. And that all of that might not be available. But I really like your example that you're giving of Bioconductor specifically. Okay, tell us a little bit about your experience.
So yeah, my experience is very much as a researcher. I got involved in a project looking at a particular aspect of sign languages across the world, and what I found amazing is being able to access the code that for R that the instigators of the project had put together, and they hosted that on Open Science. Is it OSF? What does the F stand for? I'm not sure. I'll post a link to that. So that's also a really good platform for hosting projects, research projects, where you can where you can put up all sorts of data. So you can put up your source files, right? If your actual data that you're working with, you can put up the code, the scripts that you've used to analyze your data, so that if someone comes with a similar data set, which was the case in my circumstances, where I had a very similar data set, that I then take the code that these researchers had written for analyzing their data and use it in R, and it enabled me to import packages from GitHub and edit the script in such a way that it worked on my data set. And that is so empowering, because I mean, I only started working with R less than a year ago, right? In February, that's when I did the course in R. And I mean, I'm familiar with doing statistics. I'm familiar with, the basics of coding. I learned many years ago how to code in HTML, but that's maybe not something I should mention. But I'm very much in using these tools as a supplement to my core work as a researcher. I'm not a coder. I'm not a research software engineer, but other people making their scripts available, making packages available on GitHub that you can then import into RStudio, enables me to do stuff that otherwise I would have to get grants to pay people to do. And it's just the way if you find one particular project, and that enables you to link to all the various other repositories, open source tools, and you navigate your way through this web of connections. And I mean, that's where, you mentioned that you can use your org ID on Git to link to your GitHub. The same with OSF, you can also link your org ID there. That's for me what is so exciting about making people who make their code, software, scripts, whatever, available, and people like me who use those for my own work. I'm not necessarily going to publish my adaptations, although I think having been involved in these conversations, that's my next step. To now see how I've changed the aspects of the project that I've worked on and publish it as my own project on Oats, so that someone else can then look at the two different ways that this was done and maybe find their way. So I love this networking, this web of resources, of tools that comes out of these conversations.
I'm so glad you're also mentioning OSF, because it is a fantastic resource. And I think what's also nice about OSF is that you can, in the same kind of environment, share write-ups, code, data, to keep everything together. Also for people to get a better contextual insight into what the project entails and what the code was meant to do. And I think that's very valuable. So next month, we'll be talking about documenting your code, which fits very nicely with opening up your code. But we'll focus specifically again on from very low level, very easy steps to very involved, more complex tools and technologies. But I have to hand over to Jyoti now to let's discuss the next questions. Thank you so much.
Thanks. Thanks everyone for all the discussion so far. Yeah, so the next set of questions are for Adianka and Shuma. So the first question is, and building on to the conversation. So, what are the biggest challenges you have faced in sharing code openly, and how did you overcome them? What are the practices that you follow to cite others' code, and how can others cite your code? I'm also sharing the question in chat. Yes, so over to you, Adenka.
Okay, so it's been a while like that I transitioned from core research to full-time software engineering. So I am going to be speaking from the lens of contributing to open source generally. So one thing which someone already mentioned in the chat session is maintaining your code. Researchers don't have time, to keep maintaining code that they've written for a project that they have already completed. They want to move on to something else, right? So that's a challenge. You maintaining a code that you already made open. But I think one way that we can overcome that is making it open for people to contribute and to collaborate with you, and then putting a disclaimer on your documentation. Now, documentation is key, and it's also one of the challenges of making your research code open, your research code, your data open, because you have to ensure that there is a proper, well-detailed documentation for other people to be able to see what the process of what your process was like, how to even reproduce, how to improve on your code. And from my experience, documentation is one of the biggest challenges of contributing to open source. Even currently, in the projects that I maintain, I know that a lot of our contributors, when they come in into the community, the challenge they have is, how do I even get started? There's a lot to do here. I don't even understand the project well enough. How do I get started contributing? So one thing that I try to push for is to ensure that we have well-detailed readmes, code of conduct, very important. Um, the issues that the likely issues that your code might have. If you are using a platform like GitHub, you can already have, if there's a bug with your research code, you have like a page where you can talk about the issues. So if we have issues with any of our code base, we make sure that anybody raising that issues is able to explain that issue in a way that someone that wants to resolve that issue knows how to proceed. And then if you want to also now submit what we call a pull request, that's the changes you have made to the code that you want to contribute to, you also have to make it well detailed. So documentation is a key aspect, something that is really difficult for some people to do properly, but then you can't go wrong with having a very good documentation for your code. Over to you, Chema.
Okay. Yes. So thank you so much, Dr. Adeyinka, for that. I was even going to touch on documentation, but I think you said it all. I'm a huge fan of documentation, like especially because lately I'm currently exploring the development aspect of bioinformatics, where I have to, pull command line tools and then run them on my system. And I've been having issues with bad or poor documentations. Like you just get stuck. Like if you don't know the next step, it's like cooking, and you're trying to cook something new. You don't know the next step. Documentation is like that recipe, and without, let's say there's a step to add salt, and the user skips that add salt, it's the taste of the food won't be the same as how it's supposed to come out. So documentation is super important in code writing and sharing. So I think since she's already talked about documentation and README, I think one thing I would also like to talk about is but trying to share my code, trying to make it reproducible. So when I initially started coding, there's this particular field in bioinformatics I am still very interested in GWAS. So I'm a very big fan of learning by doing and learning by sharing publicly. So when I'm learning something, I like to share publicly with the general public, by maybe posting tutorials on my GitHub, or recording my journey via my LinkedIn, right? So that other people can hop on it, and I could also receive help from experts in the field. So I think there was one time I shared a GWAS tutorial on my GitHub, and I think maybe weeks after I shared that, someone sent me a message that, oh, my code, there's an issue with a specific line in my code. So I I deleted the tutorial. So that wasn't supposed to be, right. So because that's where version control using GitHub comes in. I could have just updated it, right, and put an indication that, oh, this is the previous version of this tutorial. This is an up-to-date version of the tutorial. Then put a well-detailed README. So that's one challenge I've had. Reproducibility. That whole thing of it's worked in my system is not working in your system, right? So one solution that has really helped me with that is using session info in R. So when you're coding in R and use session info, it helps you to keep track of all the dependencies that you use, right? And also if you're coding in let's say command line, maybe using bash scripting or something, I recently discovered this one. So if you want to keep track of all the commands you used for that particular session, is similar to session info in R, but for a command line, you can use scripts, and then the whatever you want to name your file .txt. So with that, it keeps record of everything you are coding in that particular session, the results, that's the output and the input. And then when you're done, you can just use exit to exit it. So everything saves in that .txt file. So those two solutions are like my top solutions for issues in reproducibility. Another one is fear of criticism. So sharing code publicly can be very intimidating. Dr. Adeyinka was talking about sharing code. I was like, okay, because you're a pro. We that were just coming up, it's kind of intimidating for us, because you put yourself out there to people, judging the code. And funny enough, that's what we need. That's you need it to grow. You need it to if you have to look at it from a different angle, like you have to view that feedback as a learning opportunity, to engage with the community and all of that. Yeah, so that, yeah, I think that's all I have to say concerning that.
Thank you so much. Thank you so much, Emma. So I just want to correct this impression. I'm not a pro. I think what's so beautiful that something I fell in love with open source is that you don't have to be a pro. In fact, we thrive on collaboration, we thrive on community, such that even when you write your code and then you put it out there, you can invite another collaborator or another contributor to review your code, right? And once they review the code, oh, this looks good to me, or oh, I think you can improve in this particular. It even helps your research before you take it out there for reviewers and editors to look at your work. So I think that it's something that we should actually consider in the open science community, putting more of code out there for people to come together and look through. Yes. So there's another thing that I would like to add about challenges that researchers might face. One is data privacy, especially when you're working in fields like medicine, bioinformatics. You have to deal with personal information of people. You want to think through to say which part of my data can actually go out there, which one cannot. So that can actually be a challenge. You're trying to figure out how to get it out there in such a way that then you are not sued or something. And one way to overcome that is, if it's a very, very highly sensitive data, you can create a synthetic data, another synthetic. So it's not real people's data, but it's similar to real data. So we call it synthetic data that kind of like simulate the real data set that you have. Another thing is to completely anonymize the data set that you want to put out there. That is removing any traceable personal information that people can use to trace to a particular user. So those are part of ways that we can overcome these challenges. Thank you.
Thanks, Adianka. Thanks, Shoma. Those have been really insightful comments, and I'm sure everyone in the audience is finding it helpful. Our next set of questions is for Juan and Mars. So the next question is, how do you balance the need for open access with concerns about intellectual property and data privacy? How would you identify if an open source code is reusable? Yeah, over to you, Yuan.
I feel like I think you mentioned a little bit of the data piece, where not only making sure that if you're making data public, it is um, anonymized or unidentifiable of the people who are part of the study. But and I think Mars mentioned a great resource with the NASA TOPS training, where they have a complete chapter on how do you publish data. Specifically, I think for some of the things that we've seen is in terms of data and code is making sure that it's also like ethically responsible to share that data. I know we all thrive to share these components with other researchers, and we want to help other people to facilitate their research, but making sure that the data that we're sharing follows up with data privacy agreements that we've done during the surveys or the data collection process, making sure that this data follows like also like all of the policies required to share data as well, or to collect data is fundamental. So if you have the possibility of having someone from like a legal or policy team in your institution that can help you out to figure out if this is the data that you want to publish is keen or is available to be published, I think they have some great resources there already. And on the other side, I think on the side of like open source and coding, uh, there's a couple of things there with reusability. And on GitHub, something that we've done in the past few years is we have a tool called GitHub Code Spaces, which allows you to use kind of like a piece of code on the cloud or through like GitHub as a platform instead of downloading the whole code on your computer, and that is run on a container, so that anyone that tries to use this code, they have like these envelope for the code that you are using or trying to use, so that it doesn't matter like which computer or what operating system you're using, you're able to use that code without any major problems, just like by using oh my god, I forgot the name right now, but containers, and downloading the code and being able to use it. There's some other components there of reusability, like we mentioned a lot about like documentation. So very simple things in README projects, such as giving an installation guide and some first steps, go a very long way for people to be able to use the code that you have produced. So when you see kind of like, especially with, I think Mars mentioned like NumPy here, like if you see NumPy's like README is absolutely flawless. Like they have not only a project description, but they also have great guides on how to get started. They direct you to documentation. They have made it very simple for people to use the code. So reusability is not only about like the code itself, but it's also about how do we facilitate people to learn how to use this code and to be able to run it, not depending on the computer that they're using.
That's nice. Over to you, Mars. So,
Yes.
how do you balance the need for open access with concerns about IP and data privacy? And how would you identify if an open source code is reusable?
So once again, I'm going to share some links because my work is pretty unusual. And again, the best way to explain it is just to show it. I'm going to put it in the chat here. I hope all the links work. If not, the link to my GitHub will be available. And so I kind of actually want to echo some of what people already said. So Adeyinka and Chioma has said documentation is the recipe, and Johanna said something similar. NumPy has a pretty good recipe, so kudos to that. But documentation is the key to make sure that the taste is the same. And so for me, when I create comics, I feel that they are essentially the same information as the code on the page, but it's visual. So you know how you have a cookbook that just says do steps 1, 2, 3, 4, 5, and that can be kind of difficult if you don't always understand the text or you might have forgotten some things. But when it's presented very visually, you could have like step 1, step 2, step 3, step 4, and step 5. And so for me, I want to make the process of documentation easier for, say, visual learners or people who have made difficulty understanding text easier to understand. And so for me, that is like when I watch a recipe. I don't know if you all know Serious Eats. I love Serious Eats, but things like, stir the rice like this, crumble the Maggie cube like that, add a dash of soy sauce, bam, 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 it's done. It's delicious. And so for me, I want to create that kind of excitement that I see, following a recipe to following documentation for NumPy or other open source projects. So that is kind of my approach. And so the question of how do I balance the need of open access with the concerns of intellectual property, privacy, I kind of don't actually. In the context of my comics, it runs differently from code. So I'm not really concerned in the same way about reproducibility or running it on other machines. In fact, I want people to take my work and run wild. Where will they go? I want people to edit it. I want you to turn it into a meme, animate it, and put it on TikTok. I don't know. Go wild. Make your own photocopies. Have fun. Make your own zine. Color it. Whatever you want to do, it's up to you. It's out of my hands now. And I love to see what people create out of it, And so for me, like that is a different question, but it presents a different outcome. But I think something that kind of comes back to me is a question of how do I know that my comics and my work is reusable? That is actually a really good question because in one sense, with the difference between like writing code and making illustrations is that I think a lot of people in open source are really trained in understanding how to write code, unit testing, reproducibility, things like that. Very few people are trained on the art of draftsmanship, of drawing. And I do not actually expect anyone to replicate my drawings because my drawings are a style and skill that I have developed over several years. So in a sense, it's not reusable. But what I do want to make reusable is the content and the text. So one of the new challenges that I'm facing this year is actually translations. So translations in this case involve translating text from English to Portuguese, Spanish, Japanese, or whatever languages people would want. But the difficulty is that as of right now, I am the person who knows Krita, which is the open source illustration software I highly recommend if you want to break free from Adobe, because Adobe is doing their own thing. But I am very familiar with that piece of software. And if I wanted to have someone translate into Portuguese, they might need to learn how to use Krita, they might learn how to use Inkscape. And I am figuring out, well, then do I, manually translate, someone has already made a translation to Portuguese. Do I then manually update the text? Is that going to take a long time? So something that I am trying to figure out this year as well is to write a POTS file for translating it into different languages. And that should make it like more systematic and automatic, like code does. And so that is something I'm going to have to collaborate with people so that they can essentially reuse the text of the comic, reuse the illustrations, and put it in a language that's easier for them. But I think ultimately my process is similar to what Kate has said, that I'm not primarily a coder, I'm not primarily an RSC, but we're all navigating through this giant web of connections. And I'm just excited to make my work open and see what people make of my code once it's out in the world.
I just want to add a little bit into that because one of the things that we've learned from open source is that open source is not only about code, right? And specifically with RSE, there's need to be a better way to give credit to the people who are working in these projects. What I mean by that is like one of the questions that came here, which was like, I am the author of like I don't want to maintain the code, but I want to like publish my code, right? We see that a lot, and I think there's this very great great way of working out with code where you might be the author of a research project or of some piece of code, but you have other people being the maintainers and the contributors of that code. So being the author does not necessarily mean that you need to maintain the code, though like of course you're probably the person who has the most context about this piece of code and about like these artifacts. But you can always work with other people to maintain the code. And we have had hundreds of projects on GitHub where there are great libraries, and then like the maintainer is like they are fed, they want to do something else with their life, and they find either like a governance system where like they can push the code to someone else, or someone else can have like these admin access to the piece of code, um, so that they don't have to maintain it themselves. Some other researchers, what they do, or open source maintainers, what they do is they publish the code on GitHub, then they archive the repository, so they don't get the notifications from like issues or pull requests, but they still allow other people to fork the code so that they can still take a copy of the code and keep maintaining it in a different name while still maintaining kind of like that authorship of the main piece of code. So there are multiple ways. I think like specifically with like recognition of open science and research, there's still some work to do there to define a taxonomy. I've seen probably like about like 6 different taxonomies for credit. And a big part of that is kind of like the work that Mars is mentioning, right? Like if you are creating non-code contributions to these repositories or this code, it is still a very valuable contribution. Translation is also a very valuable contribution. Documentation is a very valuable contribution. So we need to make sure that we are also giving recognition to these people who might not be the coders, but that are also a very essential piece of these communities and of these like pieces of projects. So I think in terms of that, like, and going super back to probably like the last question, thinking about the ways that we build like these projects and that we give this recognition is important. And something that is very, very important, especially if you're giving authorship to someone else or allowing someone else to maintain the code, is just to make sure that these people kind of are doing the best for the code. We've seen supply chain attacks where like people get access to the code as admins, and they can do like backdoors and add like security flaws to the pieces of code. So just like taking your time to kind of like build that trust with members of your community that want to become maintainers is important, just to make sure that this code is not only open, but it's also safe to use.
Can I add to the beautiful contributions of Mas and Juan? Okay, so there is one thing that I would like to speak to. How would you identify if an open source code is reusable? So if you're coming in, you want to know someone like Kate that loves to use people's code, in our studio and all that, who is grateful for such a thing, and you would like to do that also. The first thing you do is when you get to someone's code base, like a repository on GitHub, you want to check on the kind of license that code base has. And what we mean by open source license, that's like the legal framework that specify how a code should be used by the user, right? And we have different types of licenses. I'm not going to go deep into it. I'm just going to speak at a high level on these licenses. The first one, so we have 2 major categories. We have the permissive license, and then we have the copyleft license. So the permissive license is the MIT license, the Apache 2.0 license, and the BSD license. Now, the MIT license is the one that someone like Mars is going to use. Like, I'm just so happy for me to share my code and for you to use my code. So go ahead and use it. So if you see a code base that has an MIT license, you're free to use the code, right? So it would be nice for you to know about these licenses, what they entail, so that when You then go to someone's repo, whatever license you see there, you know how far you can go with that code. We also have the copyleft license. Those ones are more restrictive because they then tell you, oh, probably you can use this code to some extent, but you cannot commercialize that code. Or even if you want to commercialize the code after you have modified it, then some part has to also remain open. That is, other people should be able to use the changes that you have made to that code and be able to distribute it. So essentially, check the contributed.md guide or the readme.md guide. Then there's an aspect for the licensing in the repository that tells you the type of licenses that that particular code base is using and how far you can go with reusability. Thank you.
So much. We're supposed to include a Q&A session, and we have so much more to discuss. I'm just thinking we could still talk about licensing not only your code but also your documentation. There's like licensing things that are perhaps not code but relates to a project under the Creative Commons licenses and other open licenses. And what about what are the evils or the benefits of creating your own license? And I'll focus more on the evils. Please do not create your own license if it's not absolutely necessary. Please start off with existing approved legally um, uh, solid licenses. Don't go and create your own license. It's probably not in anyone's best interest. So we are going to have to wrap up. And our last question for our speakers was going to ask for one piece of advice that you want to leave the audience with. Really in 2 sentences, what advice do you leave the audiences with if they were interested in learning more about opening up their code? Of an event, a workshop, a resource, a tutorial, or an online book. We'd love to hear from you. So let's go alphabetically again. Then you know who goes next. Thank you so much.
That means I go first, right? Oh, okay. So let me just say one thing so that others can also contribute. Do not be afraid to put yourself out there, honestly. Open source is free. Open source, and by free, not only is it free to use, it's also welcoming. We have a lot of welcoming communities. So joining open, whether it's open science community or open source community that have science, maybe open science working groups. We do have something like that in Chaos, whereby we have a data science working group. So if you're interested in science and all that, you can come in and then contribute. So joining open source communities, joining communities like the RSA Africa is very essential and very advantageous for you if you would want to know more. Thank you.
Okay, so one advice I would leave anyone with is that really helped me is as Dr. I think I said is to be open source, like doing it with everybody, collaboration, communication. So joining communities to, if you're stuck on something, it's always nice to have somewhere where you can, post questions, post ideas like, oh, this is happening. How can I get past this and all of that? And there are amazing communities to join. Speaking from the bioinformatics perspective, I usually share these things on LinkedIn. There's bioconductor community. It's not just knowing about bioconductor packages. You can learn about bioinformatics generally, coding best practices for biological data analysis. There's also MVIF, if you want to learn about the latest tools in microbiome research, those little bugs in our system, that keeps things going. MVIF. We also have the carpentries. A couple of them, I can post them in the chat box. Yeah, so communities is key.
Love it. Thank you so much. Juan Pablo.
I have two pieces of advice. The first one is it takes a very small amount of effort to support and kind of like help open science to be flawless and to continue kind of like working it, especially like when you're opening like your code, there's like a very few steps you can follow to make sure that you make your code findable and accessible and that people can use your code as well. And the second piece is that if you're part of an educational institution, we offer like a ton of free resources for all of you. So you just go to education.github.com and we offer things from like GitHub Pro accounts, more GitHub Actions, and a ton of different resources for you completely for free. So check it out. We even offer like GitHub Copilot for free for like anyone that is applying through these institutions. So check that out, and I really hope to see what you're building and more of your research projects on GitHub.
My advice is similar to what everyone else has said. Get involved in the community. I did, as I said, I did a course through our local escalator program that Anelda's involved with. So find resources that will help you. And what I found enormously invaluable is being able to ask people questions. So like I've asked Anelda, for example, when I've run into issues, I've been able to reach out either via email or via Slack or via community notes, what boards, message boards, whatever. There's always going to be someone who can help you answer your questions. So yeah, make use of the community and when you run into difficulties and experiment.
Fantastic. Thank you, Mars.
I'm gonna drop it in the chat so we can get it out in there. But NASA tops, don't use this code. They're great. Every month it's happening. Check it out. It's free. If you're a designer in open source, please check out open source design. It has been super invaluable for me. Finding other designers, mind blowing. Those are my two pieces.
Fantastic. Thank you so much. And I think the key here sounds like community and people. Thank you so much to everyone who joined us and everyone who joined us this year, all our speakers, all our community members. It's been invaluable to us as organizers and hosts and to people who have participated. So we really, really appreciate you.